Good evening. This is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic super heterodyne receiver. So in super heterodyne receiver, the incoming signal voltage is combined with the signal generated in the receiver. The local oscillator is normally converted into a RF signal to a lower fixed frequency called as a intermediate frequency. The signal at this intermediate frequency contains the same modulation as the original carrier, and it is now amplified and detected to reproduce the original information. The super heterodyne receiver has same essential components as that of tuned radio frequency receiver. In addition to the mixture, local oscillator and intermediate frequency amplifier is used. A constant frequency difference is maintained between the local oscillator and the RF circuits, and through the capacitance tuning, in which all the capacitors are ganged together and operated by one control knob. This is called gang tuning. And in IF amplifier generally uses 2 or 3 transformers, each consists of pair of mutually coupled tuned circuits. With this large number of double tuned circuits operating at the constant, specially chosen frequency, the IF amplifier provides most of the gain and bandwidth requirements of the receiver. The characteristics of IF amplifier are independent to the frequency to which a receiver is tuned. RF circuits are now mainly used to determine the wanted frequency, to reject the interference such as image frequency, and to reduce the noise figure of the receiver. So this is a diagram for the super heterodyne receiver. It consists of an pre-selector, RF amplifier, mixture, bandpass filter, IF amplifier, local oscillator, and envelope detector, audio amplifier, and finally speaker. So receiving antenna, the receiving antenna receives a signal from which was transmitted. It sends a received signal for further processing. RF amplifier, the received signal is fed to the RF amplifier stage, so it can amplify as the signal is get attenuated during the long distance transmission. And next is a local oscillator. This circuit basically generates a signal with a fixed frequency, and the output is then fed to the mixture. When we talk about this AM broadcast system, the intermediate frequency is 455 kHz. So local oscillator should should be in such a way that the frequency which is 455 kHz above the incoming signal should be generated. And the mixture simply mixes the carrier frequency with the frequency of a signal generated by the local oscillator. Here there are two different frequencies are to be mixed, so we have to have another component of the lower value. The summation of carrier and local oscillator frequency at the output of the mixture will give rise to an image frequency, which is treated as a type of noise or distortion. This is the reason why mixture generates a frequency difference at its output. This difference frequency is at constant value irrespective of variation of the input, known as the intermediate frequency. The constant frequency at which output is gained is called capacitance tuning. In capacitance tuning, several capacitance are arranged together and operated by a controlling knob. And next is the IF amplifier. This section basically amplifies the output of the mixture. IF amplifier provides a sensitivity and selectivity to the receiver. So as consists of several transformer consist of pairs of tuned circuits. So selectivity and sensitivity are uniform and does not show as variation as in case of the tuned radio frequency receivers, because IF amplifiers characteristics are independent of the received signal frequency. The section next is a demodulator. Demodulator is played exactly after the IF amplifier, so that constant frequency signal is demodulated and message signal can be extracted from it. And next is the audio amplifier. This audio signal is fed to the audio amplifier, which does not hold distortion or noise, so that it can amplify audio signal to the particular level. And next is a power amplifier. A signal is further amplified to a particular power level, which can activate the loudspeaker. The amplifier signal is finally fed to the loudspeaker circuit, which converts the electrical form of signal to an audio signal, which can be heard by listeners. And advantages of super heterodyne receiver is that it operates at low signal level. The mixture provides a fixed frequency operations. It provides excellent selectivity and sensitivity. Drawback is that overall system cost is increased as additional circuits are used. And next is the application of super heterodyne receiver. Super heterodyne receiver finds its use in various places, as in television, it is used in radio receiver, it is used in commercial radios. So that's all about the super heterodyne receiver block diagram. and about the advantages of the super heterodyne receiver, drawbacks of super heterodyne receiver, and also its applications. Thank you.